Hello, everyone. Today I'm going to be explaining the problem where the triangle is inscribed in the circle, which is inscribed in the square. It's also problem 9 in the 2013 to 2014 Masters contest, 7th grade. Okay, I'm going to share my screen. Hopefully you can see this. I'm just sharing the problem and the diagram. Okay, let's get started. Equilateral triangle PQR is inscribed in circle O. We'll put O right here, which is inscribed in the square ABCD. If AB, so that would be this length right here, is 12, what is the ratio? So ratio of the shaded area to the area of ABCD. So it's technically asking for this area right here. So I'm just going to highlight it. This area, so shaded to the ratio of the square ABCD. So what we could first start off with, so step 1 is to find the area of the square. So find the area of the square. I'm going to make these steps so it's a little easier to follow through because this problem is a little trickier. So we're going to first find the area of the square. And that's pretty easy because we know the formula for that is just the side length squared. So that would be 12 squared, which is equal to 144. And I'm going to put it over here so we know that our square area is equal to 144. So now we've finished step 1. So we have half of our problem because we need to find the area of ABCD. And now we need to find the shaded area, which is the green portion. And to find that, you could take the approach of finding the circle area and subtract it by the triangle area. So that's what we're going to do. So our second step would be to find the area of the circle. And that's also pretty easy because the area formula is pi r squared. But we don't know the radius. But because the circle is touching the edges of the square, we can just take 12, which is technically our diameter, and divide it by 2 to get the radius, so r. So if we do that, so pi times 12 divided by 2 squared, it's also 6 pi times 6 squared, which is equal to 36 pi. And that's our circle area. So circle area is 36 pi. So all we have left is the triangle right here. Except the thing is, to find the area of a triangle, so area of triangle, you would need to know the base and the height, because that's the formula to find a triangle, the area of a triangle, half times base times height. But we don't know anything about the triangle. So that's what we're going to find out. So here's our circle. I'm not going to draw the square for now because we had information on the circle from the past step. So here's our triangle. We know that the triangle is an equilateral triangle from the directions or the problem itself. So that means the sides are equal, and the degrees inside are all 60 degrees. So next, what you would do is you would find the height. So let me just color code it. This, you would find the height. And that might be tricky, but there's a pretty easy way to find out. So technically, the height of a triangle, the ratio is 2 to 1. So that's technically the distance from the midpoint of a triangle. This distance over here, the top, will always be twice as much as this length from the bottom. So if we use that, we can do, we can easily find our length. So now from the previous problem, we know that our radius is 6. So we can say that, so now we know this length is 6 from our ratio rule right here. So now if we do half of 6, we get 3 for this bottom length. And 6 plus 3 is 9. So our height is equivalent to 9. So that's how we find the height. Might sound a little confusing, but that's a really easy trick once you get it. So now we know the height of the triangle, but we still don't know the base. So let me just draw another triangle right here. So here's our height. So what we can do is technically we can split our triangle in half. So if we do that, it turns into a right triangle right here. And we know our height is 9. And if you also recall, this turns into a 30, 60, 90 triangle because this is 60 degrees. And we know that all the degrees add up to 180 in a triangle. So this would be left off with 30. So because it's a 30, 60, 90 triangle, we can we know that this length here, I'll just name it X, is always half of this length. So this length is twice the length of this. And that's because we're splitting the triangle in half right here. So that would divide this length over here, let me just color code it, in half. And since all lengths are equal, that's why this length is always half of this length. Oops. Okay, yeah. So now that we have a better idea of how our triangle length, the lengths of our triangle are, we can plug it into the Pythagorean theorem to find this length. Because if we know, we can put it in the Pythagorean theorem to find out x right here. And then we can plug it back in. So to do that, we can do, so our formula is a squared plus b squared equals c squared. So if we plug it in, 9 squared plus x squared is equal to 2x squared. It's important we have those parentheses over there. So let's solve the equation. So 81 plus x squared is equal to 4x squared. And if we subtract x squared from both sides, we get 81 is equal to 3x squared. And if we square root on both sides, we get, not square root. PEMDAS is very important right here. We do reverse operations. So divide by 3 on both sides. We should get 27. So 27 is equal to x squared, which means the square root of 27 is equal to x. And we can take this even further by turning it into simplified radical form. So is also equal to 9 times 3, which is equal to 3 square root 3. So that's what x is. Now that we know what x is, we can plug it back in here. So 2x. So now we know our new value is 2 times 3 square root 3, which is equal to 6 root 3. And this length is just 3 root 3. So now that we know our base, we can find out the area. We can solve this next part in 2 ways. I'm just going to explain how I solved it. So I'm going to first solve for just half of the triangle, this portion of the triangle, because we cut off half over here. So I'm just going to solve for this part now. So we can use our formula, a is equal to half times base times height, which is written over here too. Now if we plug in our values from here, actually not that one. Oops. This is 6 root 3. This is 3 root 3. We can plug in this value and this value because this is our base and that's our height. So area is equal to our base, which is 3 root 3 times 9 over 2, which is equal to 27 root 3 over 2. I'm just going to stop simplifying it right here. So that's the area of this portion. So to find the whole area of this triangle, we just multiply that by 2. Times 2, which is equal to, let's just do the math right here. So that'd be 54. 54 root 3 over 2, which is just 27 root 3. We could have just crossed these out, but now we know the area of our triangle, so we can write it up here. So our triangle area is equal to 27 root 3. So I'm just going to erase, root 3. I'm just going to erase all of this to make some room. So now that we know all of our areas, we can plug it in to get the ratio. So our ratio. So first we can get the ratio of the shaded area, which is just circle, not the ratio of the shaded area itself. So circle minus the triangle. Now that we have our information, we can plug that in. 36 pi minus 27 root 3. And then we have our square area, which is equal to our 144. And we can just put this ratio in a fraction form. So we can simplify this. Both are divisible by 9, so this would turn into 4, and this one would turn into 16. This one would turn into 3, so we get 4 pi minus 3 square root 3 over 16. And we can simplify it further because although 4 and 16 are divisible, we can simplify these two. We can't simplify this 3 over here. So our final answer is 4 pi minus 3 square root 3 over 16. So I hope this helped, and thank you for watching.